Okay, I guess it's time to get started. I'm glad to see at least some people are still here, not just out on town drinking beer or going home or whatever we're doing. The final set of sessions for this year's conference. If you're like me, you think it's been a great conference, it's good. Hopefully we can round it off well and go home knowing a lot of new things. The final talk in this track is going to be about Postgres 15. Now, I had this discussion with the conference people, unfortunately too late, that normally I like to do this talk at the beginning so that I can tell you which other talks to go to learn about more details. So if anyone has a time machine to rent to people, like we can do that. Otherwise, you'll have to go to the next conference to learn about more details. But we're going to talk about Postgres 15, which is now very close to release. It'll be released within weeks. And I think we're basically completely set as of a commit that happened yesterday on what we're going to be. But as always, I'll always tell everyone that when I do these talks, this is based on the developer version of Postgres that is there right now. It hasn't been released. Features I mentioned may be gone before the release. They may work differently.
Everyone should go to Berlin.
Of course you should. But basically, we'll go through a bunch of the new features. I think at this point we can fairly safely say they're going to be there. Now, I will say I've said that once before, and a major feature has since been removed. But it was over a month ago. So a few quick words about me. My name is Magnus Hagander. I work for a company called Red Pill Linpro. We're an open source consultancy and services shop that's based in the Scandinavian region. So I'm out of Stockholm in Sweden myself. I'm there within Red Pill Linpro. We do a bunch of different products, a bunch of different services. I lead up the database group, which does Postgres. Big surprise for all of you here, right? Within the Postgres team or within the Postgres community, I'm a member of the Postgres core team. I'm one of the committers on the code base, and I'm also serving as president of Postgres Europe, which is so this conference is organized by United States Postgres Association, I think the formal name is, or as we usually call them, Postgres US. And our group in Europe is called Postgres Europe, or Postgres EU, which does the same thing in Europe. So we do advocacy efforts, we do conferences, we do connections with people and stuff like that. So I'm involved in far too many different teams and breaking things all over. Okay, so let's talk about Postgres 15. Let's talk about where we are. And we get to the first of two of my slides that are not properly updated. We'll start with this one. So the development schedules out of Postgres 15, we started in 2021 in June, where we branched off what was to become Postgres 14. The way that we work with the development in Postgres is we have the master branch, which has the next upcoming version, and at some point we decide it is time we branch off the stable versions, call them. So we create a branch called, in this case, release 14 stable. Like that's how you make your software stable, you know that, right? If you have problems with instability, just create a branch called stable, and now you have stable software. So we created that branch, but what it really means, obviously, that's not true, right? What it means is at this point we opened up the master branch or the main branch of the repo for building what will eventually become Postgres 15. And we did the same thing this summer where we branched off version 15 and opened up the master branch. So if you were to download the Postgres Git repo and work off the master branch of it now, that would be Postgres 16. But we're not going to talk about that today. In Postgres, we use something called commit fests, but it's really just our way of doing iterative development, where the basic idea, it mostly works, but it's not as strict, but the basic idea is we spend 1 month building features, and then we spend 1 month reviewing and committing these features onto the main repository, and that's the part that we call the commit fest. So for Postgres 15, we had 5 of them, July, September, November last year, January and March this year. And since then, there have been no, like in March, at the end of March, we had the feature freeze, no more new features into Postgres 15. There were, of course, bug fixes and improvements, but like no more actual new features at that point. And then in June, we had the beta 2 release. So you can tell that's when I gave this presentation, and then I forgot to update this slide. Because of course now we are at release candidate status. Right? So if you go to the Postgres website and want to look at downloading Postgres 15, today you will get a release candidate. And if you come back in a couple of weeks, you will hopefully get the release if nothing goes, terribly wrong. It will be out there fairly soon. Who's already running Postgres 15? No one. Oh, come on, you guys are boring. Who's running Postgres 14? Okay, at least we got a couple of people there. I'm not going to go through someone did that in the opening session, right? Went through all the old versions. I'm not going to do that for you. So let's instead talk about the new features. Some of you may have seen me do these talks before. I always try to break up my talks in a couple of sections. I talk about DBA and admin, SQL and developer, specifically then about backup and replication, and of course everybody loves performance. Now what's the actual difference between DBA and developer today? I hope it's not a big difference in your organization. Then you should, if it is, you should fix it, right? This is mostly the same roles. Like we should all work together between these roles. But I just split them up. It's basically SQL and developers are things that are done in SQL, and DBA and admin are things that are done outside of SQL, because I had to split it up on something. But the traditional of we have DBAs over here, and we keep our developers in a different building or a different country. I hope you're not in that kind of an organization, because that doesn't tend to be very productive. But before we get there, breaking changes. Okay, this is not one of the worst versions. We've had versions that broke a lot of things for people. Most of these things should not affect you. For example, we dropped support for Postgres servers prior to 9.2 from PSQL, PGDump, and PGDumpall. Who's using Postgres 9.2 or earlier? Thank you. That's the one that I didn't want anyone to use. Okay, that's good. That's bad, right? 9.2 went end of life many years ago. Greg? Yes, but they have bigger problems than this. If they're using 8.4. I have customers using versions earlier than that. But they know that they have problems. Yes? Out of curiosity, what was removed that won't let you connect? Oh, you can still connect to a pre-9.2, but all the / commands don't work. Because basically at some point you can't just keep adding to it. You need to clean up some old stuff. It wasn't something that just fundamentally broke everything. It's just PSQL, for example, has many, many versions of which queries to run to implement it, depending on which version. It was just a code cleanup to get those done. Yes? I guess like Redshift has compatibility with some 8-something version. Does this affect that as well? I have absolutely no idea how it would affect Redshift, but in general, if it worked, and if Redshift looks like 8-point-something, then it will no longer work.
Based on what he said, yes, it should still work fine because the / commands weren't working for you anyway.
Oh, okay. Well, there you go. So they will just be broken in a slightly different way.
Well, I mean, those catalog tables are just not there.
Okay, yeah. But PSQL, again, the basic one, there's no protocol level change. So that part should still work. Okay, Postgres has dropped support for Python 2 in PL Python, right? Many distributions had already done this. Like if you were using Debian or Ubuntu, for example, this was already dropped there because Debian and Ubuntu had dropped Python 2, and there wasn't really any point in supporting PL Python 2 if you didn't have Python. Python 2 itself, the entire platform, end of life in January of 2020. So if you are dependent on Python 2 or in your stored procedures, again, you already have a problem. It just made it a little bit worse.
Just in time for Python 4.
Yeah. So, and PL Python 3 obviously still fully supported. Something that is more likely to break things and should break things is the public schema has new permissions. In particular, the public role no longer has create permissions on the public schema. By default in your existing servers, if you didn't read all the Postgres security announcements saying don't do this, or like go change this, any user can create an object in the public schema by default. In previous versions, no more. Super users, of course, can do it. And the database owner can still create objects in the public schema. Nobody else can do that. The public role retains usage permissions. So if you, as a database owner, create a table in the public schema, other users can still access it through the public schema, but they cannot create new objects. Now, this is a good thing, right? But it may break your applications. It's pretty easy to fix, but it may break them. Don't fix it by granting public back this permission, right? There is a reason for this change. And another important thing to consider there, if you do a dump reload, right, check up what your permissions actually end up on the other end, so that you don't end up indirectly this way putting that back. Of course, we don't see a lot of dump reloads as upgrades as many as before these days, right? We mostly use PG upgrade or something like that. And yes, sir.
PG upgrade's going to bring that permission right back.
Oh, that's right. PG upgrade is actually going to bring the permission right back as well. That's true. So yeah, if you're upgrading, you might just want to go in and change it back to where it is. And yeah, if you dump reload, because that part of dump reload is actually used in PG upgrade as well. But if you're doing like a replication-based upgrade or something, then this will not happen. The other thing is the exclusive backup mode has been removed. It has been deprecated for like 10 years because it is unsafe. Like you can end up, if your system crashes at specific points while you're taking a backup, it will not start again. Like that's a bad thing. I think most people can agree that that's a bad thing, right? The non-exclusive mode of the API level still works. Use PG-based backup. In general, take this as a good idea. If your backup scripts crash because of this, because you wrote your own backup scripts, this is an excellent time to throw those away and switch to one of the ready-made backup solutions like PG Backrest or PG Barman, or just PG-based backup if your demands aren't high enough to need one of the other tools. But get away from writing your own scripts, because you will have made a mistake. And I promise you, you did not cover for the fact that your system could crash and not come back, because there was actually no way to avoid. There was, no matter what you did, there would be a race condition where that could happen. But yeah, take a chance to get out of those. Hopefully this doesn't affect you, because hopefully you didn't do this, given that it has been deprecated that long. But sadly, many people did. Okay, those are the things that broke. Let's talk about the things that we did that actually, made your life better, not worse. Within DBA and admin, let's start with something small. You can now have root-owned SSL private key files in libpq. What the hell does that mean? Well, it means if you're using SSL authentication, TLS authentication, previously Postgres would just reject your files if they were owned by root. In a previous version, we fixed it to allow it in the backend, but on the client, we still didn't allow it. This tends to be a problem in like containerized environments, which is the only case where we actually run things as root now, right? But people seem to like containers these days. We're supposed, like a lot of development, we're supposed to do that, and we wouldn't really support it well then. So, simple, trivial fix. In the Postgres path to get rid of requirements for superuser, well, we now have a new role called PG checkpoint that allows you to do checkpoint. Okay, previous versions required you to be superuser to do that. Narrow scope, right? It's a very narrow scope, but there is an ongoing effort to like chip away at everything that requires superuser and turn it into one of these predefined roles so that you can stop giving people superuser access and instead give them a much more granular access. Because, as I'm sure you all know, if you give people superuser access, they can upload programs to your server and run them. That's probably not what you want, right? Another thing that we can do is we can now set permissions on GUCs. GUCs is one of those wonderful internal terminals, right? Does anyone who's not a Postgres developer, because I see some of you in here, know what a GUC is? You might know what it is. Yes?
I just know.
Yeah?
Oh, the settings you can set?
Yeah, correct. Like, these are Postgres settings. Do you know why it's called a GUC?
I knew it, but I forgot.
It is the grand unified configuration. Because at one point, Postgres had a bunch of different places to set different configurations, and when they were all put together, they were put into a file called GUC for the grand unified configuration. Anyway, so superuser GUCs, or superuser configuration parameters, you can now reduce the permissions on them. So you can, for example, reduce in that like superuser can still do. So for example, the parameter track functions, you can grant a set permission on it. You can grant set, so in this will allow Joe to change the parameter track functions without being a superuser. And of course, you can do the same. You can also say grant alter system on parameter, which allows this user to permanently change the value of this parameter. This is far from getting, like you can grant these users permissions on them. You can't revoke from like regular. Something that's often asked is, for example, can we make people not allowed to change workmen? It doesn't do that yet. Like it's a start of a process to make the permissions more granular and to be able to do it. For now, you can grant it in one direction. Hopefully, we'll get the other direction later. We have some new parameters to look at. We got something called shared memory size, and the wonderful, as you know, named by committee, shared memory size in huge pages. It's a beautiful name of a parameter, isn't it? The use case for these are not things that you can change. These are the type of parameters you can view. And the idea behind this is that you can ask a Postgres installation, how much shared memory does it need? And because shared memory, most of you will go like, well, that's shared buffers, right? You configure that in shared buffers. But there are other things in the system that use shared memory. And there could be extensions that use shared memory. And one of the main reasons for this, actually, I mean, the main reason for having shared memory size is that we actually want shared memory size in huge pages. Because if you want to configure huge pages on a Linux system, for example, you might want to know how many. You have to reserve this amount of memory in the kernel. And previously, the way to do it in Postgres that was beautifully documented is set the parameters you want, restart Postgres, watch it fail, because it will not start, read the error message, do some math on the output from the error message, and then change your kernel and start it again. Not a very user-friendly way to do it, right? The idea behind these is you can now say Postgres-C, which will show you the value of the config parameters, and you can say Postgres-C shared memory size in huge pages. It comes out and says 72. So that says, okay, you need 72 huge pages to run Postgres with the current configuration. Then you can go change that before you restart Postgres. And it will actually not die, which is kind of useful. Can also be used as input to an automatic config system, for example, that will read the Postgres file and reconfigure the kernel as necessary. We got some enhancement to the tools. Who in here is using PGStats statements today? The rest of you should look into PGStats statements. I'm really hoping that one day I will not have to say that, and everybody will just use PGStats statements. It's an excellent way to gain insights into your system. The new things we have in PGStats statements this year is I/O timing for temp files. So if you have I/O timing turned on, you can see exactly how much time has been spent reading and writing the temporary files. These are the ones, when workmem, when you don't have enough workmem, we spool to disk. How much time did that take? How much time do we spend on it? And we get counter, again, per statement, per SQL statement, right? That's the point of PGStats statements. We get counters for JIT operations, the just-in-time compiled, like how many times has it done, how much time has it taken. It's a way to track down things that, sadly, things that are running slower than they should. The biggest problem with JIT today, I think, is when it kicks in when it shouldn't and makes things slower. This gives you a chance to track that down better. Further on the topic of monitoring, we have some new wait events. I think this is pretty obvious what they do. The archive command wait event shows that this process is running an archive command and waiting for it. These are just to complete your list if you are monitoring these things. Archive cleanup, restore, they're all very given. There are some interesting changes to logging that you should not be too scared about. One of them is the startup process. So when Postgres starts up, it runs crash recovery, similar processes. When it starts up, every log startup process interval, which by default is 10 seconds, it'll write a line to the log telling you what's going on. So if it takes you 2 minutes to start Postgres, it'll say, I'm still replaying transaction log and I'm this far ahead. So it suddenly becomes, if your startup takes more than 10 seconds, it will no longer just be the silent process that you have no idea when it's going to finish. And it will actually tell you what's going on. Obviously, you can change this. 10 seconds is probably a good default. Log auto vacuum min duration has now been turned on by default. Right? In previous versions, you have to turn it on yourself. It's not on by default. Now, by default, any auto vacuum process that takes more than 10 minutes will get logged. So it's like your slow query log. Right? We've only and the parameter has been there before. We've just changed the default. We've turned on log checkpoints by default. So in a standard or unconfigured Postgres system, you will now get at least one line of log every 5 minutes. if there is anything going on in your database, because then a checkpoint happens and it'll get logged every time. If you don't like that, well, it's a parameter. You can turn it back off. We have a new logging destination that is called Json Log. Works just like CSV log, but instead of writing a CSV line for every log line, it's a JSON line, or JSON object, or whatever you want to call it. Always written to a file, just like the CSV log. All fields are always included, just like the CSV log, except now you also get the field name repeated on every row, because every row is an independent JSON object. It's obviously a lot less efficient than CSV log in that it does that, but it has the advantage that we have a lot of log management tools out there today that like structure data in JSON format, and then you can feed this just directly in there and be able to do it. If you're going to do like some people, like if you're going to analyze it in a Postgres database, just use CSV log. That'll be more efficient. But JSON log can be very useful when you're shipping this off into other systems. Okay. We now have something we call security invoker views. By default, a view in Postgres does not have this, right? So if you create a view and then somebody else queries through this view, they will access the underlying tables with your permissions, with the permissions of the user that created the view. If you don't want that, you can now say this with security invoker equals true. At that point, if I create a view and Bruce queries my view, it will access the underlying table with Bruce's permission, not with mine. So it's a way to like turn off this feature of a standard view. And I have a spelling error. There you go. Permissions are hard. So the default is, again, to do exactly what we did before. The default is what the SQL standard says it should be, right? But you now have the ability to turn that off. A feature that is very useful to a lot of people from my end of the world is that the ICU locales, right? You know, Postgres can use ICU to add more locales than just what your operating system has, and does do it in slightly different ways. You could previously not have these locales being the global locale provider. So you had to then have both your operating system locales and your ICU locales. Postgres 15 will let you have it globally. Will be able to specify it per cluster when you do initdb. For example, I can say this is SVSE would be the Swedish locale for Swedish, Sweden locale for Swedish. Or when you say create database, you can say locale provider ICU to tell it to use the ICU locales all the way through. Obviously, life is easier if you can just stick to, you know, US ASCII 7. World was easier back then. I don't think even you guys can get away with that now, right? Okay, moving on to look a little bit at the SQL and developer side of things. What do we do there? We have some interesting additions to the numeric data type, of which I think one is useful and one is kind of like, okay. You can add a negative scale to a numeric, which will basically make it round off, right? Now, if you say, let's say numeric 5,1, right? That's what we had before. That means you got 5 significant digits, of which 1 digit is to the, to the right of the decimal point. Right? You can say numeric 5,0. That basically means it's an integer. Right? Also, don't do that. Like do use numeric 0 for integers if you are going to store integers that are bigger than an int 64. If your integers are not going to be bigger than an int 64, use that, or sorry, int 8 is what we call it, like a 64-bit integer, big int or int 8. Use that because it's going to be much faster than numeric. But you can now, the new thing is you can now say numeric 5, -1. As you'll notice, then it will just round off, so you will now have a certain number of zeros at the end. This may be not what you want to use for your columns, but you can cast to it as part of your calculations to get it going there. If you do use it for a column, will it use less space? I don't actually know how much we optimize that. I don't think it does. I think it just controls the input and output of it. I think it's the 5 that's going to control the size of it. Of course, if you're looking at like low numbers like 5 to 10 digits, like the space is not really going to matter. If you're starting to look at 100-digit long numbers, then it might matter.
Well, it's var ln x, so it's whatever you actually put in.
Yeah. You can also now specify a scale that's greater than a precision. which I'm not entirely sure, but I guess it is. Today, you cannot store things like 0.010. It will come back as 0.01. And you get that. And by in this case, you can say the scale is actually going to be bigger than the precision. I'm not entirely sure how super useful that's going to be. But, maybe it is. You can now do what we call partial set null on your foreign keys. You have your column, you have a multi-column foreign key, and you references the other table. If you say on delete set null, it would set all 3 of those columns to null when this happened. You can now say only set column 2 and 3 to null and leave column 1 at the previous value. This is pretty useful if you're having like multi-tenant system where, for example, the thing that I call column 1 here would be like your tenant ID. And you're saying set null, but it keeps which tenant this row belonged to and sets the sort of application level keys back to null. Which was really complex to do before. Well, I mean, it was complex in that you had to build your own foreign key management, and now Postgres will do it for you. And we all know that it's better that way. So this one's interesting. This time I'm talking at a Postgres conference, so you all know this, right? Unique indexes or constraints versus nulls. Assuming I have this table here, right? Create table A, integer, unique. And then I insert the value 1. Okay, we're all there. That works fine. If I were to insert another one now, I get a unique violation, right? Then I insert the value null. And then I insert the value null. And what happens? Right? We have basically 2 options here. Either it succeeds or I get an error. Who would like to vote for it succeeds? Okay, a couple of people. Who votes for it fails? Okay. Who has no idea? So it succeeds because nulls are a null does not equal null. Right? But sometimes you actually want it to fail, and the annoying part is different databases do this differently. Right? Some databases this will fail, but on Postgres this will not fail. So the new thing that we have here is we can create our index by saying nulls not distinct. And when we do that, well, if we do this, and then this, and then this, and then boom. Okay. So if we say nulls not distinct, it will actually fail. I'm honestly not, like, nulls should not be, like, Postgres is doing it right. I do firmly believe that Postgres is doing it right. I believe firmly that this will be really helpful in migrations from systems where it doesn't, because you can get really interesting bugs when you have a system that relies on this not being the case. So it's a really useful feature. The syntax is defined in the SQL standard, so it's not even a Postgres invention. But the fact is we can now do both ways, so we don't have to argue which way is right. You can just choose. And of course, instead of saying unique nulls not distinct, you can say unique nulls distinct. Right? They work, just changes back to default. At the SQL level, the really big thing is merge. And this is where I'll say Simon had the talk a couple of hours ago about this. So merge is not a replacement for OnConflict that Postgres has had for a bunch of years, right? The insert blah blah on unique conflict do something. It solves a different problem in a different way. You can kind of sort of solve the upsert problem with merge. You solve it much better with insert on conflict. In particular, you solve it much more performant with insert on conflict. Merge is for merging. And one interesting note is that merge is not atomic in that insert on conflict is guaranteed that it will succeed if you specify it right. Like, it'll do one of the 2. But merge, you can actually end up in the classic of you try to insert, it fell. You try to update by merge. It fails, okay, because the row doesn't exist, and then while you move on to the next step, somebody else inserts that row, and you still get a unique violation, right? That can happen with merge. That cannot happen with OnConflict, which is why when we're doing this classic, I'm inserting a new value, but if it's already there, I want instead update. Insert OnConflict is much better. But merge solves a lot of bigger problems, a lot of different problems. Merge does not operate on a single row. It operates on a set, which is the really big difference, right? And what the basics of merge is, you join a target table with a source of data. And you define rules for what happens when these things match and don't match, and update the thing that is the target table. So a merge will only update the target, or it will insert into the target. Merge, the way it is, it can never update the source. There are databases, I think, that can do a merge that updates on both sides, but Postgres can't. So what does it look like? So simple. You start by saying merge into. This is similar, like, I would say insert into, but we say merge into. Okay, merge into target. Target is the name of my table. I'm just going to alias it to T because I'm lazy and I want the font to be as big as possible. Then I say using changes. That is my source table. So I got a table called changes that contains some sort of changes. I'm going to alias it to C. I'm going to take those changes and put them into target. This is my join clause. Right? I'm joining the two, saying that the target.typeID should be the changes.typeID. Basic inner join syntax. Right? So if I instead of saying merge into did select star from target T, inner join changes C on type, like this would be the rows that I'm going to change. And then I can set a bunch of rules. Right? So I'm saying when not matched, okay, that means basically when there was a row in changes that did not have a corresponding row in target, and the value delta in this change had a value greater than 0, then I'm going to insert. And the insert, you see, the insert just says insert values. It doesn't specify where because the changes always happen in the target. So it's then going to insert into the target table c.name and c.delta, so the name and the delta fields from it. And if it's done, if it's not matched and the delta is greater than 0, we're done. If this did not match, we move on to the next rule. Next rule says, okay, when matched, okay, that means there was a row here that matched. And the value of t.num, which is the column in the target table, plus the delta is greater than 0. So that means the delta could be minus and we could end up with like a 0. This could be like a, tracking stock in a warehouse or whatever. Then we update. Again, the change always changes the target. We say, okay, set the num in the target to be the sum of what was there before and the delta that came in from our change. And finally, we're saying, okay, if it's matched, but the value of t.num and c.delta is not greater than 0, which means it's either 0 or negative, then delete. And then it just deletes the row from the target table. So this is, you can specify, I think I asked Alvaro at some point in one of these talks, like, you can specify an unlimited number of rules. It's limited only by, the length of a SQL query in Postgres, which can be like a gigabyte, and the time you're willing to wait for it to actually parse and run the statement. But like it's not like you only can have like 1 or 2 of them. You can have as many as you need. So using this, like this is a really powerful way of again, merging, thus the name, merging changes from like somewhere else into your database. But again, if what you are doing is simple row by row upsert, use insert on conflict. That will be more efficient. Merge is more powerful. And we're solving slightly different problems with them. Okay, moving on to the next subset of features, backup and replication. Logical replication now supports replicating two-phase transactions. Like it can replicate the transaction in the prepared state. I would say that's a pretty narrow use case, but again, like many narrow use cases, if you need it, you probably really need it. Most people don't use that much two-phase commit. You can now publish all tables in a schema, and you cannot do it using this syntax, because this was that final thing that went in yesterday. Create publication for all tables in schema. It's for tables in schema, the all is not there. So syntax change. Functionality is still there. Previously, you could say for all tables, right? And then it would take all tables in your whole database. But if you wanted it for an individual schema, you had to like loop over them and add them one by one. Convenience feature, but a very convenient convenience feature. More powerful thing in logical replication is that we can now do row filtering. So for each publication for a table, you can add a where clause. So here we're saying, create the publication for my table XYZ, but only replicate the rows if column is greater than 10. Yes, well, either one of you two. Yeah.
So what happens if the row has column 1
What happens if it moves between them?
and the update now does not have to?
So I think, and I will admit, I don't actually, I've thought of that myself and I forgot to look it up before. I think what happens is if you, like, it looks at the new value. And if you're changing it to something that's not included, it doesn't get replicated. Yeah. I don't think you get a delete, but that's the part that I'm honestly, I don't know for sure. You're going to have to test that. It is a very good question, and I really should know that, but I don't. So that's row filtering. The other thing that we can do that I think a lot of people are really going to like about logical replication is we can now do column filtering. So you can replicate a table, but not all columns. This can be really useful in all of these scenarios where we're maybe replicating into a different security domain, where we're saying, well, these columns contain sensitive data, so don't replicate them. Only replicate the insensitive data over here. And you just say, well, I mean, you say for table, and you can just list the columns. It can be for security or sensitivity reasons. It can obviously also be for performance reasons. You don't need them, so don't replicate unnecessary data. We have some other things around logical replication. We have more statistics. There is now a view called PGStats subscription stats on the receiver side. We'll have per subscription statistics. There is an option on your subscription that can say disable on error, which means that if you get an error, it'll stop trying. Like right now, if you get an error, because you can get these interesting things when you've poked the data on the receiving side and like inserted data, and then you can get a unique conflict, or you've added constraints on the receiving side that didn't exist on the publishing side, it can just fail. And right now previously in Postgres, it would just keep trying like forever. And if it's probably not going to solve itself. You can now just say disable on error, in which case if this happens, it'll stop trying and leave it up to you to fix it. Speaking of fixing things, this is a really dangerous feature. You can now say alter subscription skip. And if it's stuck, if it gets an error on a specific thing that it's trying to replicate, you can say, well, just don't replicate that and move on after that. That can give you wonderfully inconsistent data, right? Because normally you can't just skip one update, for example, and just do the next. But if you know exactly what it is and exactly why it's a problem, and you know that it's safe to skip it, you can do that. But yeah, this is a very large foot gun if you don't know what you're doing. So don't go here until you really need to. But it is very useful to have it, because previously the way around that would be, of course, oh yeah, let's rebuild this table's replication from scratch. And that, if it's a large table, that's painful.
Does that have to point at the begin statement or the commit statement?
Does it have to point at the begin or commit statement? It points at an LSN. I think, yeah, if it points, like if you move it into the middle of a transaction, I think it'll actually like that. No, actually no. If you skip inside the middle of a transaction, that should be fine.
But are you setting the LSN to the commit LSN, like skipping a specific commit? Or are you, because like...
No, I believe you can skip inside of a transaction as well. Like I said, you can do a lot of damage with this.
So what about...
Because it's logical.
You can probably skip to the inside of a wall record.
No, it will align to like the individual like, because this is logical replication, right? These are rows of data that comes over, so you can point it at an individual row.
If you have like interleaved transactions, often the case where you have a problem, you only want to skip like one transaction, right? But you can have another one that's in flight that you don't want to skip.
Yeah, and yeah, this one will skip everything to this LSN, so it doesn't solve every problem, sadly. You can then skip the whole thing and manually make, again, this
Just by like setting confirmed.
this one more or less does, yeah, it just skips up that part. So it's a very dangerous tool. But it is there, and yes, there are good use cases. And I think if you have a if you have a complex flow of data, you're not going to want to use this. But in some cases, like if you have a simple flow, but there's a lot of data, you can like bypass a few things. But I worry that this is going to be like PG. Who's ever used PG reset xlog, or now called PG reset while? Okay, I'm glad that the people who are putting their hands up are people I think know how it works. I've seen far too many people who used to do that because, oh, I got an error on startup, I'm just going to do, I Googled it, I got a Stack Overflow, it said use reset while. That one intentionally corrupts your database. But it starts, but like you can't just reset while and move on, and this is sort of the logical replication version of doing that. So be very careful about that one. Updates to base backups. These are the built-in base backups, the one that PG Base Backup uses. Like the low-level APIs, we got rid of the exclusive mode, but the other ones aren't affected. We now support server-side compression, so if you used PG Base Backup before and you added compression, we'd send the data uncompressed to PG Base Backup, then compress it and write it. You can now have the server compress it, send it first. Very useful if your connection is metered, for example, if you're sending your backups over an expensive connection or over a slow connection. And of course, you can still do client-side compression as well, but you have the option of doing server-side compression. You can even use server-side compression combined with client-side decompression. If you're, for example, provisioning a new replica over a metered connection, you can have just the transferred data be compressed and then directly into it. No, most of the time, if you're using it for a backup, you'll compress it on the server and then just keep it compressed. But for replicas, it can actually make sense to do both ways. Base backups can now be given base backup targets, which is where are they going to send the result of the base backup. So normally, you would have the thing that's called client, which is you run PG Base Backup, the file gets sent across the connection back to PG Base Backup. You can now run PG Base Backup, have a target being server, and have the server write the file directly on the server. There's also a black hole target, which just throws your backup away. You don't use that for actual backups. I mean, they're very cheap. They don't use up a lot of storage, but they also don't really work. The log archiving part of our backups has now been given the ability to run as a loadable module. Right? Today, you have your archive command that points to a shell script or a binary. This can now instead be a library that's linked into Postgres because we're calling this once every 16 megabytes. Right? And if you have a very high rate, the overhead of just running a shell for every file is noticeable. It is also, I say, it's easier to make reliable. Well, reliable. It has a neater API. The only way that a shell script or a script of some kind can tell Postgres that something went wrong, please try again, and things like is by an exit code. This archive library has access to more internal state of Postgres. It can do more things around it. Most of you will probably never write one of these modules. But the expectation is that your tools, like Backrest and Barman and those tools, will eventually get to a point where they will ship one of these libraries instead of shipping an archive command. By default, we ship an archive library that implements the archive command, just like before. And if you don't configure anything, that's the one that it's going to use. So nothing changes, but it gives you the ability to do that. There are many things you can do if you're having performance problems with your archiving. Making your wall size bigger will solve one problem and exchange it for another, but it is one of the options you have. Tools out there, again, don't write your own, but some tools out there like Backrest and Barman, they will have the ability to parallelize compression, archive. There are ways to solve it. Hopefully the idea is, given that these archive libraries will give you more control or give the author of this tool more control, they'll be able to use that to improve further. Speaking of having performance problems, we've done some good things for performance too.
What?
Yeah, I'm sorry. We've added 2 new compression types to Postgres. You can see after for years and years and years only having one and saying no, then we added 2 at once. So we have LZ4 and set standard, depending on which external libraries are available on your system. They can be used for while compression. They can be used for base backup compression. And LZ4 can be used for PG receive while compression. They're both going to get there eventually, right? It just didn't make the cut for this version. Both of these are excellent compression methods. They generally don't compress better than what we have today, but they compress way faster. It's not just a little bit faster, it's a lot faster. Yes?
What about toast compression?
We don't. No, sorry. We did. We added toast compression for LSAT 4 in the previous version, right? And I don't think we do set standard yet. The problem with toast compression is we're really sensitive about which methods to add because we have 4 bits to control it. So there is a limit. I think it's 4 bits. Or is it maybe it's even 2 bits and it's 4 numbers. Because we stole some values in a 32-bit field. Like it's tricky. That's why none of this has been done years ago. Parallel query. We can now parallelize distinct. I still stand by the fact that most of the time when I review like our client's applications, and there is a distinct in a query at the top level, it usually masks a problem somewhere else in the query, right? So your first thing should be find that problem. Like it's a join clause that's missing one join clause or something like almost all the time. But if it isn't, your distinct will now actually run faster. Right? That is useful. Our partitioning can now do what we call ordered partition scans in more cases. In particular, it can do it for list partitions. What does that mean and why do we care? Well, partitioning will be faster. That's to the point that we really care. This one I like to put in just so people realize. Monotonic window functions can now have smarter planning. Who knows what a monotonic window function is? I'm glad that nobody put their hand up on that, including the people who are Postgres developers. It's very simple, really. Row number is an excellent example of a monotonic window function, right? It will start by 1 and then it'll go 2, 3, 4, 5, 6. This type of query is common, for example, if you're migrating a system from Oracle, because Oracle doesn't have limit on select. This is how you do limit on select in Oracle, right? You do a select from subquery, and then you say where rn, in this case, which is going to be the row number, less than 5. Oracle is smart enough to not run this query to completion. Postgres on previous versions will run the inner thing here, like g, from egg. It'll run the entire query, get the row number of 1 billion rows, and then throw out everything except 5, right? And that's the difference. It doesn't do that anymore. Yes?
I know that some other databases, BigQuery being one of them, has support for a qualified keyword, which is basically like a filter on a having clause. So you can effectively without doing the subquery there, you can qualify that and say qualify rn less than 5. Has there been any talk of doing that?
I haven't heard any talk of doing that, so I don't think so. I may be wrong, but I haven't heard of it. Postgres statistics, previously stored in files, are now stored in shared memory. No longer temp files. We no longer use UDP over localhost, which is kind of a weird thing to do. So some crazy error messages go away. If you are monitoring what's running on your system, there will no longer be a stats collector running. That doesn't mean it's broken, right? On previous versions, if your stats collector isn't running, you don't get any stats. Lots of things break. This is okay now. It's not supposed to run. We're storing this data directly in shared memory. Better performance, lower overhead. Everyone's happy. We have recovery prefetch. We will prefetch when Postgres does recovery. It'll use fadvice to tell the system that it's going to be reading more data. Operating system dependent, currently only supported on Linux, I think. But most of you are running it. No, it's some other things, but it's specific, like it's not supported on Windows, and I think it's not supported on macOS. But it is supported on most of the ones. Should just make recovery faster. There is always going to be more features. There are more performance features. There are more features of other kinds. Yes?
The advice in the previous slide, is that just to read the wall segments, or is it like...
No, I believe it fadvises the pages that it's going to be working on.
That's what I was wondering.
Yeah.
So it's
Yeah.
like so it must be processing the wall ahead.
Yeah. Exactly. So again, there's always going to be more, but I am basically out of time. He's smiling over there. He's like, yes, I get to kick him out. You do get to kick me out. Anyway, there's always going to be there's a lot of smaller things. There are always more performance things. I have some contributors in the room. If I didn't mention your feature, sorry. But you have to choose. What was it? Bruce I think you had a number of how many features are typically in a Postgres version. It was like 180 or something like this. So we don't have time to go into all of them. I would recommend, again, if you have a time machine, go back and look at some of the talks earlier at this conference that talk about these features in more detail, like merge. If you don't have a time machine, you can buy an airplane ticket and come to Berlin, for example, for the big European conference, where there will be talks about most of these features, or any of the other upcoming Postgres events. Please do help us. Again, we don't just have a beta version, we have a release candidate version. It's up there. Download, install, test. Right? Run your tests. Let us know how it worked out. At this point, we're probably not going to have time to fix it. Well, if something is broken, we really want to know. But we're also interested in knowing things like, did we have a performance regression somewhere that we missed that shows up on your systems? The sooner you let us know, the more likely that we can fix it either in the release or in the first minor release coming after it. Right? It is a release candidate. We do generally consider a release candidate in Postgres does mean that we hope to release the same code. Now that did not happen, particularly the syntax for the all tables in Schema has changed from the release candidate. But other than that, the changes between the release candidate and the release are expected to be almost nothing. Right. So it should be safe. It is there. There are apt packages if you're on Debian Ubuntu. There are RPM and Yum packages available if you're on a Red Hat-based system. There are Windows installers available if you're on Windows. Like, these are all available. So please grab them, test them, let us know how it worked or how it didn't work. With that, I'll say thank you. And I think we all need to file over to the closing session right away, right? Yep. So feel free to grab me after the closing session if you have any further questions. Thank you.
Thank you so much.